Hello, Daily Math Blast Week 2, 5 NBT 1 Place Value Relations. Write the value of the 7 in each number. Well, if we look, we see the 7 is in the ones place. Therefore, it is worth or has a value of 7 ones. The 7 in the next number, right here, that is in the thousands place. Therefore, the value or worth of that digit is 7 thousands. Compare the value of the 9 in each number. So if I look at the 9, first number, I have it right here, that's 9 hundredths. The 9 in the first number is in the ones place. Now, comparing the value, I could go least to greatest or greatest to least. It doesn't matter. I'm going to compare the value of the 9 ones, this number, to the value of the 9 hundredths in this number. So 9 ones is... Now, to determine the value and to compare these 9 ones. Now, to get the 9 in the hundredths place to the ones place, I would have to shift it 1, 2 times. So that's multiplying it by 10 once, and then multiplying it by 10 again. And I know 10 multiplied by 10 is 100. So therefore, 9 ones is 100 times greater. Put an H in there. Than 9 hundredths. Now I could have compared 9 hundredths to 9 ones also. 5 NBT 2 II, whole number exponents for powers of 10. Here we have standard form, repeated factors, and exponential, and we're just converting from one to the other. So when I look at repeated factors, we're talking about repeated factors of 10. So we're going to start with 10. And now what I have to ask myself is I'm going to multiply this by 10 until the digits shift to match 100,000. So 10 multiplied by 10 would be 100. Multiplied by 10 would be 1,000. Multiplied by 10 would be 10,000. Multiplied by 10 would be 100,000. So therefore, my repeated factors are 10, multiplied by 10, multiplied by 10, multiplied by 10, multiplied by 10. Now, exponential form is a more efficient way of writing those repeated factors. So my base is 10. That's what I'm multiplying by. And now my exponent is how many of those tens? Well, I have 1, 2, 3, 4, 5. 5 tens. So 10 to the 5th power. Now, in the next one, I have the exponential, and I need to work my way back. So the base is 10. That's what I'm multiplying by. So 10. And then the exponent is 3. So I have 3 tens. So 10 times 10 times 10. Okay. Now, to turn that into standard form, I just need to start with 10 and then shift the digits each time I multiply by 10. So 10 times 10 is 100. 100 times 10 is 1,000. So if you just think about the decimal point stays and the digits shift. Now in the last one, I have the repeated factors, and I'm being asked to turn it into exponential form and standard form. So first, I'm going to turn this into exponential form. So I have 10 is what I'm multiplying by, and I have 2 tens, so 10 to the 2nd power. Now, to turn it into standard form, I have 10 times 10. Well, if I have 10 and I multiply by 10, that's going to be 1 shift, and so that's going to be 100. 5 NBT 3A, reading and writing decimals. Here I have standard form, unit form, and expanded form. Now, expanded form, I can use fraction notation or decimal notation. And if you look at my examples, we have one that is in fraction notation and one that is in decimal notation. So I can choose whichever one I want. So the first one here, I have standard form, I have unit form, and I want to write it in expanded form. if you want to think of expanded form, just think about I'm writing the value of every digit that makes up that number. So I have 5. Well, that is in the thousands place. So I have 5 multiplied by 1,000. And now I'm just going to build this number using all of these values. Well, the next digit I have, going left to right, is a 3. Well, that's 3 times, and it is in the 100s place. So 100 plus, now I have to kind of move down because I'm out of room. The last digit I have is the 2, and that is in the 100ths place. Now, I could write that as a fraction, or I can write that in decimal notation. It doesn't matter. So 1/100th. So I could have also used the 100th as a decimal. Now I have unit form and expanded form, and I'm being asked to convert that into standard form. So I have 6 10,000s, 2,000s, and 500ths. Okay? So I have 6 10,000s. So what I'm going to do is I'm going to kind of put, and then I know I have hundredths. And change my color here to make it a little easier to see. So I'm kind of thinking of those as the place values I'm more likely going to need to fill out. So if I look, I have 6 in the 10,000s place. Well, if I look here, I have a 6 in the 10,000s place. I have a 2 in the thousands place. So I look at my place values, I have a 2 in the thousands place, and I have a 5 in the hundreds place. Now, using this strategy, if you have enough of one unit, you may need to build a larger unit out of it and add to it, but this gives you a good starting point. Now, I need to put placeholders in there. Well, my placeholder is 0 because I have 0 hundreds, 0 tens, 0 ones, and 0 tenths. So 62,500ths. 3 and 500ths. Now, I have the standard form, I have the expanded form, I'm being asked to do unit form. Now remember, unit form, there are many correct unit forms. There's only one correct standard form. There's one correct expanded form. We can just write it in fraction notation or decimal notation. But unit form is where we have a lot of flexibility. So here, they're asking us to write this number in tenths and hundredths, and those are the only two units I can start. Well, if I look at this number here, my largest unit is going to be tenths, so I start at the left, and I look and I say, okay, so here is from the left all the way to the tenths place. So I say, well, how many tenths do I have there? Well, that would be 30 tenths. Now, I have to use 30 because I don't have any ones to build my number out of, so I need to turn all those ones into tenths. Now, I have 5 hundredths remaining, so 5 hundredths. So this is a version of unit form that would match that standard form. Five NBT 2I, patterns for powers of 10. Find the value of n in each number sentence. Show how you know. This is very similar to a question that we were working on before. When we multiply by powers of 10, the digits shift to the left or to the larger place values. When we divide by powers of 10, the digits are going to shift to the right or the smaller place values. So I have 1 and 5 tenths multiplied by 10 to the nth power. And this is true for all positive numbers. So I have 1 and 5 tenths multiplied by 10 to the nth power equals 150. So that tells me my digits are going to shift to the left. So I start with 1 and 5 tenths. Now, I need to shift my 1 to the 100, to the hundreds place. So one shift is going to get me to the tenths place, and another shift is going to get me to the hundreds place. Now the 5 needs to shift from the tenths to the tens. So one shift, 2 shifts. And then here's my place value. Here's my decimal point, and here's my place value holder. So I built the number 150. Well, how many shifts did I need? I needed 2 shifts. Therefore, I need to multiply by 10 2 times. So n equals 2. 2 and 4 tenths divided by 10. So I'm going to build my number here on my So I got 2 and 5/10. Now, I'm going to divide by 10. Well, that means my digits are going to shift to the right. So I put my place value holder there. So I divide by 110. So my number goes there. 110. So my number goes there. So 24 hundredths. And we like to put that 0 in the ones place. It just makes the decimal easier to read. Identify the triangle by sides and angles. Provide evidence for your side angle choices. Well, there's a couple things going on here. So first, sides. Equilateral means all 3 sides are identical. So when I'm looking at this triangle, there's a couple things I can notice. Well, number 1, I know we're talking sides, but if you look right here, there is a 90-degree angle. So that is a 90-degree angle. Well, I know all 3 angles add up to this angle here and this angle here. They add up to 180. Well, if this is 90, then these two have to add up to 90. Therefore, they cannot be 90. So that tells me if the angles aren't the same, the sides are not the same. Now, an even easier way, that's kind of the mathematical reason. But if you just simply look, you can see that this side here is much shorter than this side right here. Okay, so we know it's not equilateral. Now our next question is isosceles. Well, isosceles is 2 or more. So all 3 could be the same or just 2. Well, if I look at this triangle, I can see that all 3 sides are of different lengths because these 2 are the closest, right? But this one, if you notice, it takes a straight path from this point to the 90-degree angle. And if you see this one here, it takes kind of a slanted path to the same point. So that means it must be longer. So that means all 3 sides must be different. So it is definitely scalene. And why? Or because all sides have different lengths. Like I said, there's a couple ways I can prove that, is the angles, and I can also kind of use logic. Like I said, the straight line and the diagonal line. Angles. Well, we already kind of talked about angles. So we notice right here in this corner piece right here, right there, that is a right angle. Well, we know if a triangle has a right angle, we call it a right triangle. When I'm identifying triangles, what I look for is I look to see if it has a right angle, therefore it's a right triangle. If it has an obtuse, or an angle slightly larger than 90, then it is an obtuse triangle. And if I can't find a right angle or an obtuse angle, then it's acute by default. So this triangle is a right triangle because it has a right angle. And that's kind of the symbol for angle. So I'm going to use that since I'm kind of running out of space. Okay. So there we go. That was Daily Math Blast Week 2. Thank you.